Binder is a tool to share Jupyter notebooks in an executable environment. In Binder, notebooks are interactive, so anybody can play with our code and make changes, and reproducible, so anybody can rerun our code and obtain the same results. It is an excellent tool when we want to share our research outputs with colleagues, attach an interactive notebook to our publications, or teach small classes and workshops. How does it look like? It is a Jupyter notebook that runs on a server technology called Binder Hub that creates interactive computational environments in the cloud so that anybody can run and/or modify the notebook. As an example, in this video I will use a Jupyter notebook where I create a map showing publications about knee cartilage segmentation. I made this notebook for a previous video on how to create reproducible computational workflows. You can find the link in the description below. There are 3 simple steps to share a Jupyter notebook using Binder. First, we have to create a file called requirements.txt that contains the packages our code uses. Then, we add our Jupyter notebook and requirements.txt to a repository, and in this example we will use GitHub. And finally, we create and launch a Binder repository. The first step is to create the requirements.txt file that contains packages we use in our code together with their versions. To create the file in JupyterLab, we can click on the plus at the top of the file browser panel, and then in the launcher under Other, we click on Text File. We can see that the new file appears in the file browser panel. To rename it, we right-click, rename, and type requirements.txt. Now, how do we know which packages we used and which versions? The easiest way for me is to look into the dependencies that I print out at the end of my notebook. I explain how to do this in the video about how to create reproducible computational workflows, whose link you can find below. I copy packages and versions and I paste them in requirements.txt. Here, I substitute the space between the package name and its version with equals, and I save the file. The second step is to add the Jupyter notebook and requirements.txt to a GitHub repository. If you don't have an account, just go to github.com and sign up. The procedure is very standard. You click the Sign Up button and follow the instructions. Once logged in, we want to create a new repository for our files. To do so, in the repository page, we click the green button New, and then we fill out the fields. For the repository name, I choose cart_seg_liter_map. The description is optional, but I just want to write a little explanation, like interactive literature map of knee cartilage segmentation publications. I want the repository to be public. I initialize the repository with a README file. I add a license, which is very important because without a license, other people cannot use my code. In this case, I choose the MIT license. And finally, I created the repository. Here are the license file I've just created and the README file. The very easy way to add any file to GitHub repository is to drag and drop them. So I grab my files from the folder I have on my other screen and I drop them into the repository. I fill out the commit changes by typing adding notebook and requirements for Binder, and I commit. And finally, here we can see the requirements.txt file with packages and versions, and here a static version of the Jupyter notebook. The last step is to create the computational environment in Binder. So we go to mybinder.org and we just have to fill out these fields. Our repository is GitHub, but we can see that there are other repositories that one can use, not only the ones of the Git family, but also Zenodo and Figshare. Then we have to add the repository name. To do so, we copy the URL of our repository from GitHub and we paste it here. Under Git branch, tag or commit, we type master because our files are in the GitHub master branch. And finally, we added the relative path of the notebook. Since our notebook is in the master branch itself, we just copy its name from GitHub and paste it here. And we launch. If we click on Show, we can see the building process. It takes a while because Binder is creating a whole computational environment, a sort of mini computer or virtual machine that contains everything we need to run our notebook. In the while, we can get the badge to add to the README file on GitHub. We copy the link for Markdown files, we go back to GitHub, we press the little pencil to edit the README file, we paste the link, and press Commit Changes. Here's the badge. Anybody who goes to our repository can access our Jupyter notebook in Binder by pressing this button. In the while, the creation succeeded, and here is the notebook in Binder. As I said at the beginning, on Binder we can reproduce the computations that are in the notebook. To do so, we clear all the cell's outputs by going to Cell, All Output, Clear, and we see that the outputs get deleted. And then we can rerun the whole notebook by going to Cell, Run All, and recreate the same results as before. On Binder, we can also modify a notebook. For example, in this case, it could make sense to reduce the size of the map because it goes out of the field of view. So I'm going back to the code and I changed width to 800 and height to 380. I press Shift Return and I get a smaller map that fits in the field of view. More information about Binder are in their documentation website. We can find information about getting started, how-to, tutorials and in-depth guides, sample repositories and configuration, and the Binder community. In the frequently asked questions, we can see that users are guaranteed at least 1 GB of RAM with a maximum of 2. Binder will automatically shut down user sessions that have more than 10 minutes of inactivity, and how to cite them. If you have any questions or comments, do not hesitate to write them below.